Hi class, are you ready for a new lesson? If so, let's begin. So our first lesson for this morning is about the internal structure of our planet Earth. But first, let us state our objectives. So here is our learning objectives for our lesson. You will be able to define the different components of the Earth's internal structure, appreciate the significance of the Earth's internal structure, and identify the Earth's internal structure based from your understanding. So I have here an egg. What do you observe about the egg? Does the egg reflect our internal structure of our planet, or does it not? If you observe the egg has a shell, right? The egg also has its egg white and then the yellowish yolk. And just like our planet, it has these different parts as well. So let's proceed. So just like the egg, our Earth also has similar components in its structure. First, we have the crust. So just like the egg, the outermost layer of our Earth is known as the crust. Then below the crust is the molten rocks, which is very hot, which we refer to as the mantle. Then below the mantle, we have our core. So take note that our core has its outer core and inner core, which we will discuss later on. First up, we have the crust. The crust is the outermost shell of our planet. And did you know that it contains all known life in the universe? The crust, however, it is really thin compared to the other layers of our Earth. The crust is about 40 kilometers or 25 miles, containing 1% only of the Earth's total mass. The crust and the upper portion of the mantle is a part of a single geological unit called the lithosphere. The crust is composed of sedimentary rocks, igneous rocks, and metamorphic rocks. And try to guess which of the three mentioned is the most abundant rocks found in the crust. If you guessed igneous rocks, then you're correct. The igneous rocks is formed when magma is cooled down. So here are examples of igneous rocks. So next we have these metamorphic rocks. So these metamorphic rocks have undergone drastic changes due to pressure and heat. And lastly, we have sedimentary rocks. Sedimentary rocks are formed when sediments or materials are accumulated at the Earth's surface. The Earth's crust is divided into two types. We have the continental crust and the oceanic crust. So now we will try to go deeper below the crust. So if you still remembered, I mentioned earlier what was the second layer of our Earth's internal structure. If your answer is mantle, then you're correct. So the mantle lies between the super dense crust and our superheated core. So the mantle is really thick. Guess what? The mantle contains 84% of the Earth's total volume because the mantle's thickness is 2,900 kilometers or 1,802 miles. The rocks that make up the mantle are mostly silicates. So these silicates are rocks that are formed from silicon and oxygen structure. The temperature of the mantle varies greatly, from 1000 degrees Celsius near its boundary to the crust and 3700 degrees Celsius near its boundary to the core. Speaking of the core, why not we discuss the core itself? So the Earth's core is the very hot, very dense center of our planet. The Earth's core is like a ball shape that is found at the center, lies beneath the mantle. So the core is divided into two regions, or it has two layers. We have the inner core and then the outer core. We will discuss first the outer core. So the outer core's thickness is about 2,200 kilometers or 1,367 miles. So the outer core's temperature ranges between 4,500 degrees Celsius and 5,500 degrees Celsius, composed of liquid, nickel, and iron. Since the outer core is a liquid metal itself, it has low viscosity, meaning it is easily deformed and malleable. So with this, the core has been the site of violent convection currents, sustaining and creating our Earth's magnetic field. While the inner core is a hot, dense ball made mostly of iron, the temperature in the inner core ranges about 5,200 degrees Celsius. But with a temperature that is above the melting point of the iron and other metals found within the inner core doesn't behave as a liquid. Instead, it behaves as a solid due to intense pressure. Right. The intense pressure restricts the movement of the iron atoms and other metals found within the inner core, resulting it from behaving as a solid rather than a liquid. So the intense pressure is about 3.6 million atmospheres. Unlike the outer core, the behavior of the elements in the outer core behaves as a liquid. And since we're done discussing the core, let us first have a recap. What was the first layer that we discussed earlier? So the first layer of our Earth's internal structure is the crust. Next is the mantle, and last is the core, which has two layers, the outer core and inner core. So now we will try to discuss the importance of the internal structure of our planet Earth. I will show you images of which you may comment below and share your ideas. So we have Earth's gravity. Earth's gravity comes from all its mass, and our mass of the planet comes from the internal structure itself. Imagine having only two layers. What would you think will happen? The lesser amount of mass a planet has, the lesser amount of pull or gravity, just like the moon. So we may be as floating or like in space, but thanks to the right amount of the internal structure of the Earth, we have the right amount of gravity, not pulling us too much or not having us floating around. We also have land formation. That's right. Land formation, which is the result of plate tectonic movements. So these plate tectonic movements are driven by the convection currents found in the mantle, or the second layer of our Earth's internal structure. So the mantle that drives convection currents, so it results from either separation of the plate boundaries or converging them, or either sliding past through, which then forms land masses, such as mountains, rift valleys, and much more. So third, we have the Earth's magnetic field. The Earth's magnetic field is a result of the churning metal found in the outer core, which then creates and sustains our magnetic field. And having without a magnetic field would mean we're dead because of the what? So the sun produces harmful rays such as solar winds that may kill life itself. So with the magnetic field, we are alive today. Fourth and the last, we have life. Yes, you and me is alive because of the internal structure of the earth. So the internal structure of the earth is designed to sustain life. Unlike other planets, they are not able to sustain life itself. But thanks to our right amount of how our planet is structured, life can thrive and be sustained. So, you're lucky enough to live in this planet. And that ends our discussion for the internal structure of our planet Earth. Thank you for listening.